we're going to try to do here is to work through several examples of going back and forth between the exponential form of an equation and the logarithmic form of an equation. In the videos yesterday, we carefully went through why this exactly equals this, and it's better really to understand why, but we can use the rules of logarithms to go back and forth, and I want to do that first. So if someone gives us the left-hand side, let's just write this down here, right? What can we do to both sides so I have a logarithm? Well, what I can do is take the logarithm base 2 of both sides. So all I'm going to do is take the logarithm base 2 of the left-hand side and the logarithm base 2 of the right-hand side, like that. Now, what I want to do now, we could use more properties, but I want to use the definition. How does log base 2 work? It says, write whatever's inside is 2 to a power. It's already 2 to a power. Then just give me the power. Give me the power. And so what I get 5 equals log base 2 of x, which is the right-hand side. So I can go from the exponential form to the logarithmic form just by taking logs of both sides. What if I want to go from the logarithmic form to the exponential form? Let's see, I'm going to write the right-hand side. There we go. Now this is important. Remember that taking logarithm base 2 and 2 to the ing are inverse functions of each other. They undo each other. Now, to go from the left-hand side to the right-hand side, we took log base 2 of both sides. To go from the right-hand side to the left-hand side, if we're really going to show how to work, instead of taking logarithms, we're going to go 2 to the, right? So I'm going to go 2 to the left-hand side equals 2 to the right-hand side, like that. Now the right-hand side is just 2 to the 5th. No need to fix that. What in the world is this? Well, that is one of our properties of logarithms. We can memorize it if we want, but it's really, really important that 2 to the and log base 2 undo each other. So log base 2 did something horrible to x, and whatever it did to it, 2 to the completely undoes it, and you just get x back. There's a lot of different ways of explaining that. We can remember this without killing ourselves, right? I have my little song that goes 2 to the 5 equals x, and you can see that's exactly what I wrote down, right? So there's ways of remembering it, there's ways of understanding it. We're probably going to need both. Now, that probably is enough of an example, but what I want to do is to do a couple involving e. It can't hurt. So for example, if I say something like e to the x equals 5, and I want the logarithmic version, what I'm going to do is take log base e of both sides. But remember, log base e is ln. So I'm going to take the log base e of the left-hand side equals log base e of the right-hand side, like that. Now, what in the world is left-hand side? Remember, that's log base e of e to the x. Well, log base e says write the inside as e to a power, already done, and then the log base e says the answer is just the power, and we get that. So writing down e to the x equals 5 is exactly the same thing as saying x equals the ln of 5. Let's go the other way. If I write down something like, let's see here, how about the ln of x equals 3? And I want the exponential form. This is log base e, but the way people usually phrase this, and we're going to try to stick with that, is remembering that taking logarithm, natural logarithm of something, is the opposite operation to taking e to the. In other words, if I take e to the both sides, the right-hand side is just e cubed, which I'm happy about. What in the world is the left-hand side? Well, whatever evil thing ln did to x, e to the completely undoes it. That's exactly the definition of ln. E to the and ln of undo each other. What we're going to get is x. We can do this with properties if we want, but it's really, really better in the long run to try to remember and use the fact that e to the and logarithm of undo each other. Okay, that's enough for this part.